So our first shortcut is called the angle-angle similarity, okay? And what it says is that if two angles of two different triangles are congruent to each other, then the triangles have to be similar. So if you know that within your two triangles, you have two pairs of congruent angles, then you know that those triangles have to be similar by the angle-angle similarity. So in the first example, it wants to know, are these triangles similar, and how do we know? If they are similar, it also wants us to write the similarity statement. So let's look at my first pair of triangles on the left-hand side here. So, the only shortcut we know at this point is angle-angle similarity. So that means I have to show I've got two pairs of congruent angles. Do I have any at first glance?
Yeah, 45.
Yeah, we've got R and V that are congruent because they're both 45 degrees. So it gave me those two angles. But I have to find another pair.
Angle WSR and VSB.
And how do you know that WSR and VSB are congruent? Good. They're vertical angles. You're talking about your angles here in the middle. So WSR is congruent to VSB. So does this meet the condition of angle-angle similarity? Yeah. It said that if I have two pairs of congruent angles, then my triangles are similar. I've just shown I've got two pairs of congruent angles. So therefore, we can write our similarity statement. So similarity statements, we talked about this last week, are extremely similar to our congruent statements. You have to line up those corresponding pieces. So if I were to name my first triangle WRS, then what would the second triangle have to be named? Yep, good. BVS. And the reason that we know that they are similar is by the angle-angle similarity. If we look at my second set of triangles here, again, we're looking for two congruent angles. Do I have any congruent angles? Good, we got two angles that are 70 degrees, so what angles are those?
L and R.
Good, so angle L is congruent to angle R. They're both 70 degrees. But in order to use angle-angle similarity, I have to find a second pair of similar, or congruent angles, rather. So, where can I find those, or how could I find those?
I would add 70 and 30 and subtract it from.
Good. We need to figure out what my missing angles K and P are, okay? So in order to do that, I'm going to have to add my angles that I have, and we know that all those angles in a triangle have to add to 180. So if I take 30 and 70 and add those, what does that give me? 100. Subtract from 180, what does that leave for angle K? 80 degrees is angle K. Now, you may already be able to look at that and determine what you've got. If not, what can I do to determine for sure?
Well,
Yeah, look at my other triangle. Do 70 plus 85. Subtract that from 180, so what does that leave for P?
30.
Nope, not 30.
45.
25. Good. So, are these two triangles similar?
No.
Nope, why not? Good. We do not have two congruent angles. I only have one pair, okay? And my other corresponding angles are not congruent. So they are not similar. So you can just write not similar. So our second shortcut is the side angle side similarity. With this shortcut, just like with my congruence, you've got two sides and an angle. However, the difference with the similarity shortcut is that my sides are not congruent, they are proportional. So what this says is you have one congruent angle, and the sides that are making that congruent angle are proportional to each other. Meaning that if I compare the corresponding sides and I look at their ratios, they're going to reduce to give me the same exact ratio. Okay? So you have to have two proportional sides. The angle between them, or the included angle, has to be congruent. Third shortcut is the side-side-side similarity. This one tells you that if you compare all three pairs of corresponding sides, that they will all be proportional. They will all three give you the exact same ratio. Okay? And if we have that, then we know that they're similar. So let's look at some examples that uses these. Alright, so on example 2, it wants to know, are the triangles similar? And if so, write the similarity statement. So look at the information that you're given, and which of my 3 shortcuts do you think might be possible? Yeah, all I have here are 3 side lengths. I don't have any way to get any congruent angles because I don't have verticals. I don't have any parallel lines. So the only option that we have is side, side, side. Okay? So in order to prove a side, side, side similarity, I have to look at each pair of corresponding sides. Now, when you're trying to establish proportionality, all you have to do, the order of the pieces doesn't matter. You're just trying to show that if I compare these 2 triangles and these 3 pieces, then that's going to give me the same ratio. That's all I'm concerned with. So in terms of, does it matter whether I use the big triangle or the small triangle first? It does not if you're just trying to establish if they're proportional. Okay? The way that I usually set this up is I just start with the shortest pieces and then work my way up to the longest pieces. And what this does is this guarantees if I'm looking within these 2 triangles, my corresponding parts are going to be in the same relation. So for instance, the shortest side of the smaller one is going to correspond to the shortest side of the larger one. Okay? So let's start with the shortest piece of my triangle SUT. So what's the shortest side there? Yep, ST, which is 6. So we've got 6. So it's going to correspond to the shortest of my larger triangle, which is 9. So there's my first pieces. My 6 and my 9 correspond. Okay. Let's go next to the medium pieces. So what's the medium side of my small triangle here? 8. And it corresponds good with 12. And then that leaves my longest sides, which are 10 and 15. Now, to set this up, you could have very easily put the large triangle on top, and that would have been perfectly acceptable. However, if we do that in one of my ratios, you have to be consistent with all 3. So I use the small triangle first in my first ratio, so I have to continue to use the small triangle first in my other 2. Okay? Had I used the large one first, then I would have had to have done that as well. Now, so once you've got your 3 ratios set up, you can't just automatically say, yep, they're all the same or they're not all the same. What do I have to do with each one of those? Yeah, we've got to reduce them or simplify them, okay? Because each one of these will simplify. If I look at 6 and 9, what goes into both 6 and 9? 3. 3 goes into 6 twice and into 9 3 times. So the first one gives me a 2 over 3. The second one, what do 8 and 12? What factor do they have in common? 4. 4 goes into 8 twice and into 12 3 times. And then the last one, 10 and 15, what do they share? 5. 5 goes into 10 twice and into 15 3 times. So, are they proportional? Yes, they all 3 give you the same exact ratio, which means that this does meet the conditions of side, side, side. So the last thing that I want to do is write my similarity statement. So I'm just going to name the first one SUT. What would the second one have to be called then? All right, well, let's look. Look at your sides. S here is between the shortest and the longest side. So if I look at my biggest triangle and go between the shortest and longest, that's going to be X. U was my other smaller angle, so that's going to correspond with W. And then T and V are my 2 biggest angles, so they correspond as well. And these are similar by the side, side, side similarity. Again, example 3 is just asking, are they similar? Write the similarity statement if so. Okay? So what's something that you notice right off the bat that you're going to have to do here?
Add up the sides.
So we said that in order to get my larger triangle here, because notice you've got your small triangle down here in the corner, but then you've got your larger triangle that goes from K to M to N. So to get the sides of that larger triangle, because we know that we're going to have to do some comparisons between the small and the large, then I'm going to have to add these sides together. So what is K to M? 10. What about K to N? 15. Good. Okay. So we've got two pairs of sides that we can compare here in just a moment. But I need a third piece of information. So which shortcut do we think that we might be able to use here? Which one did you say? Okay, side, side, side. But do I know 3 pairs of sides? No, I only know 2, right? Do I know 2 pairs of angles? I don't know 2, but do I know 1? Look at the 2 triangles. What are they sharing?
They're sharing K, angle K.
Yeah, they're sharing angle K, right? So if they're sharing it, is it congruent to itself? Yes, okay. So we know here that angle K is congruent to itself. What property? Good, reflexive property, okay. So they're sharing angle K, and then we've got 2 sides. So the only option that we've got here is side angle side. So I've got to show that my 2 pairs of sides that I have are proportional. So if I'm looking at my smaller triangle, it has a side length of 8. What side will it correspond with? Yep, my 10. And then if I look at my bottom piece, what's its ratio going to be? Good, 12 over 15. Now, you could have just as easily used your larger triangle on top, but had you done that in the first one, you also have to do that in the second one. Be careful, because on problems like this, a lot of times students will try to use my 2 and 3 in those ratios. You do have to use those to help you, but however, you're not using those numbers individually, because you're not comparing that little shape on the end. You're comparing your 2 triangles, okay? So let's simplify these and see if we get the same ratio. So 8 over 10, what does that simplify to? 4 over 5, good. And what about 12 over 15? Yep, they're both divisible by 3, which does give me 4/5 again. So is this side angle side similarity? Yes. We need to write the similarity statement. So I'm just going to name the first triangle LKP. Then what does the second one need to be called? LKP. MKN. Good. And this is by the side angle side similarity. In the second part of this section, we're using the fact that we know that triangles are similar to help us set up a proportion of our sides. And if we've got a missing piece within that proportion, then we can cross multiply and help solve for that missing piece. Okay? So here it's telling me that these 2 triangles are similar, so that I automatically know that I've got 3 pairs congruent angles, 3 pairs proportional sides. Okay? So the first thing I'm going to do is I'm going to label my pieces here. So it says AF is 15, TL is 3, AY is 21, and it's asking me to find TM, so I don't know what that is. I'm just going to call it X. Now, this one you can kind of look at the picture and determine what is going to correspond with each other. If you couldn't do that, you could also look at that statement and determine which pieces you're going to correspond as well. Okay? So either way, you can kind of figure out what pieces you're going to correspond. We know they're similar, so we know their sides are proportional. So I need to figure out what's corresponding. So if I have my 15, what does it correspond with? 3. And then what's my other pair? Good. And I have to use my 21 first since I used my 15 first. I used the bigger triangle first, so I have to be consistent within both of those. Now, how do I solve something that looks like this? Cross multiply. So 15 times x, 15x, 3 times 21, 63. Okay. Is this going to give me a whole number? Nope. Okay. Divide by 15. Let's reduce it. So x will be, what does 63 and 15 both have in common? 3. 3 goes into 63. How many times? 21. And 3 goes into 15? 5 times. So x would have to be 21 over 5 in order for these two triangles to be similar and those ratios to be proportional. Alright, so in example 5, it's telling me again that these triangles are similar. Okay? And it wants me this time to find 2 missing sides. So it's giving me some pieces of information in my picture, and I've got to use those to help me find those missing sides. Now, can I find both of those sides at the same time, do you think? Do you think I can find those both at the same time? No, we can only do one unknown at a time, okay? So, essentially, you've got 3 pairs of proportional sides, but you've got to kind of look at what you've got and see what you can use, because we can only use two of those ratios at the same time, okay? So, I'm just going to start, and let's just do WV first. So, I'm just going to call WV, I'm just going to call it an X. Okay? So, what is WV, or my X there, what is it going to correspond with?
4.
Yeah, X is going to correspond to 4. But I need to set it equal to a ratio that I already know both pieces for, because I need to know what it needs to be equal to. So which sides can I use, or which numbers can I use to help me with that? Which pair of sides do I know both pieces? Yeah, my 10 and my 5. That's the only pair that I know both pieces. Which one's going to have to go on top, the 10 or the 5? Good. I used the X on top, which was part of the larger triangle. So therefore, I have to use the 10 on top. From here, we're cross multiplying, solving it for X. 5 times X is 5X. 10 times 4, 40. So what is X? 8. Good. So WV is 8. So LA, I'm just going to call it Y. Okay, you could call it X again. It really doesn't matter. You could call it whatever you want. Okay. I'm still going to use my 10 and my 5 because that's the only pair that I know both pieces for. Okay. So Y is going to correspond to what? Good. And it does not matter which one you put on top. If I put Y on top, then which one of my 10 and 5 will have to go on top? Yep, the 5 is going to have to go on top. Y was part of the smaller, so therefore the 5 has to go first. Cross multiply. Y times 10 is 10Y. 5 times 6, 30. Divide that by 10. What is Y? 3. Good. So LA would have to be 3. And again, this one is pretty easy because what's the ratio between these two? Yeah, it's double. If I look at the smaller one to the large one, it's double. So, you could probably have looked at this and said, oh, well, if I'm going from 5 to 10, then that's being doubled. So that means I need to double my 4 to give me 8. And then I need to take half of my 6 to get 3. Regardless, you need to be able to know how to set up these proportions because not all of your ratios are going to be really easy to spot. Like I said, if it's double or triple or quadruple, it's pretty easy to spot. But other than those, it can get a little harder.